Hi, everyone. This is David Ryan from Chesapeake Systems. Good afternoon.
Perfect. Okay, let's get the show on the road here. So my name's Don Chenard, and I'm with Nexan. And this conference is being sponsored by Chesapeake. And David Ryan, I'll hand it over to you to give us a little bit of background on Chesapeake. Then David will hand back to me, and I'm going to pull you through all of this material that I have meticulously assembled for you on overcoming VM storage bottlenecks. So with that, David.
Thanks, Don. I'm David Ryan, Marketing Director here at Chesapeake Systems. My contact info is listed on the slide, but just remember our website, chesa.com, and you'll always be able to get hold of us. Now, some of you are already very familiar with Chesapeake Systems, but for those of you who are not, we are a systems integrator based out of Baltimore, Maryland. Yeah, how about them Ravens? And now, of course, as we approach springtime, it's time to say go O's. We're very loyal to our Baltimore sports teams, of course. Our workplace is very cool. You can see the church there. It's led by our renovation efforts of our CEO, Mark Dent. We now work in this former Methodist church, originally built in 1879, here in the Hamden section of town. This part of the city was the former mill area of Baltimore, and it's now been transformed. It's really a fun place to work, and we hold numerous public events here. At Chesapeake Systems, we say that we provide creative IT for the creative professional. We work with clients in helping them derive solutions to their digital workflow challenges. And while we handle all enterprise storage situations, we have a particular forte within the IT-centric media systems integration space. In other words, we work a lot with video entities, including independent production companies, sports teams, broadcasters, and international media corporations. I know some of our clients are in the audience today, so I just want to give a special shout out of appreciation to them. Thank you. And we would encourage everyone to visit our website, chesa.com. And when you land on our site, we suggest you go to either our Pro Video or Enterprise landing pages. The website is full of info that you will find both informative and engaging. We've had a really strong relationship with Nexan over the years, and we continue to be very impressed with their innovation. And this webinar today about hybrid storage is a perfect example of that innovation. Now, we have two very tech-savvy sales team members here at Chesapeake, Nick Gold and Merrill Davis, who pride themselves in listening to you and working with you to come up with solutions that meet your needs. Nick will be back from vacationing in the Caribbean next week, poor guy. And Merrill Davis is at a proposal meeting today. But be assured they are very knowledgeable about the line of Nexan storage options. And they will be glad to talk with you in more detail about your particular situation. Now, the best way to reach Nick or Merrill is through prosales@chesa.com or 410-752-3406. All right. Now, by the way, Nick and Merrill are also the co-hosts of our popular audio podcast series, The Workflow Show, which we invite you to take a listen to. So some of the show titles include Storage Sanity, the NLE Wars, and Archive versus Backup. You can access it on our website or subscribe via iTunes. Again, we appreciate this opportunity to showcase storage solutions from Nexan, and we look forward to talking further with you. So with that, I'll turn it back over to Don.
Great. Thanks so much, David. So let me start out just with a little bit of company information here. As you might be aware, Nexan was recently purchased. So we started as a company based in Thousand Oaks, California, which is down in the LA area, in 1999. and we've been leaders in capacity optimized storage. We have a history of technological innovations. We have 33,000 systems installed worldwide with 11,000 different customers in 60 countries. Recently won a Red Herring 100 award because we're such a hot storage company, and in fact we're so hot that we were just purchased by iMation. So now we're a $1.3 billion company, part of it. iMation, of course, has over 1,000 employees, more countries, 100 countries, and there's two big business units here at iMation. One of them is the one you care about. It's the Tiered Storage and Security Solutions Division, because that's the one that includes Nexan. And as you can see, we cater certainly to the film and TV segment. You see some names here of some companies that are using our product, and we're really out across a whole number of different industries. Some of these people need sequential throughput, and some of these people need IOPS and low latencies, and some people need both. So we've designed systems to meet the needs of these customers, and you can get a feeling for kind of the smattering of where we're selling today. And the systems that we have is really three. In this conference, we want to focus on VMware, and so we're going to be talking about the NST5000 and why that's going to help you, how that's going to help you overcome some of your VMware bottlenecks. But we have the E-Series is really the basis of everything we have here, because that's where the hard drives go. They go in the best chassis in the world, bar none. You don't pay a high price for it. We have excellent pricing here, but this is the best chassis. Any engineer working here or for any competitor would have to agree. It's extremely well designed, and I'll talk about a little bit about the features of it. Then you can take and you can put in front of that E-Series, you can either put NST5000 heads or you can put Asurion heads. Well, why would you put an NST5000 head? Well, what that's going to get you is unified, so you're more than just SAN. You're able to do SAN and NAS. And you're also going to have the ability to put fast-tier solid-state caching into the head, which is magic. And we're going to get into that, especially for VMware. Makes a big difference. The other thing you can put in front of the E-Series is you can put an Asurion head. And this would be the case when you need to, perhaps you're trying to offload primary storage and shoot it off onto the Asurion. We have a little offloader that you install on your Windows server. Maybe you're trying to achieve some compliance issues, corporate compliance or even regulatory like HIPAA and, Sarbanes-Oxley, things like that. And also, the Asurion is cloud ready because it has multi-tenancy built in, and it has awesome separation between the different users of the archive system, because each user can have their own area within the Asurion, and all of their data can be fully encrypted. Asurion comes with a built-in enterprise-class key management system. So this is the best security. As long as you don't give your key to someone, they're not going to get at your data. If they climb over the cubicle through some miracle into your part of the Asurion, they're just going to see garbled information there. They're not going to see your data. So that's some of the aspects of the Asurion. But enough on that. Let's get to the main topic here. So the pain. We have to just sort of look at the situation, see what the need is, and what some of the pressures that you're feeling as you go more and more towards virtualization. So the thing about vSphere is that it needs a very high number of random IOPS. Now, here's how this works. Let's say, and you're thinking, hey, I'm NVIDIA, I'm in the video industry, I'm a sequential guy. Well, okay, here I have 6 servers, and they're all exhibiting sequential access patterns, sequential writes and sequential reads, and that's why I've sort of got the lines going across. It's sequential. But if you take a typical vSphere server, we'll have up to 14 virtual machines running on it, and even if these servers were having sequential accesses, when you put them up on top of vSphere, to the storage system, the accesses look random. So now this changes a lot about how you think about your storage system. Before, you were optimizing for sequential reads and writes, and now you're optimizing really for IOPS in order to get all of the virtual servers properly fed. So The brute force approach to get random I/O performance, of course, is to use SAS drives. Faster goes better. And the other thing that I can do is I can use lots of SAS spindles. I can use just part of the platter. I can do what's called short stroking. And if I put enough spindles together, I'll be able to hit some very high performance numbers. The problem with this approach of throw a ton of SAS drives at it is that it ends up having a very large rack footprint, very high power consumption, poor utilization, especially if I do short stroking to get the maximum performance. It's expensive to purchase and it's expensive to operate. So there is a smarter way, and the smarter way is to use flash. You want to have solid state as part of the picture because it really does magic things for the value equation, because it pumps up that random I/O rate by 3 to 10 times without adding very much to the cost of the system. So now you can have a system that, hey, if people are accessing the NST5000 sequentially, you know, they're going to enjoy the performance level that they're getting. And if you're in a virtualized environment, they're going to be seeing the same kind of good, smooth performance, SLAs being met. So when I think about Flash and I think about the overall architecture in the IT department, I think, well, you know, there's really 4 places I can put Flash. The first is I can go ahead and take like a Fusion I/O card, something like that, and just pop it right into an application server. Now, what that will do is it will make that one server go faster. The downside is none of the other servers that you have are going to go any faster, just that one. But, you know, maybe it's a vSphere server so that, you know, it has merit. Now, the thing is that that flash card, it can cache the reads, and that's where it's really getting its performance from, but typically does not cache writes. Because should the card go bad, then all the writes would be lost. So writes are typically, you know, this caching, when you put the card into the server, is typically a write back cache. Would be the best situation. That's how you're going to get your highest performance. But these cards, unfortunately, are write through cache. So everything's going well until you have to write data, and then you're going to wait until the rotating media transaction can be acknowledged. So there's your problem there. The second thing you can do is you can go with a pure solid-state storage system. That's good because it's a shared resource, and a number of different application servers can now have very high IOPS. Unfortunately, the capacities will be small, which I know kills you guys, and the price will be very high as well, and so these things need to be considered. The third approach you can take is you can say, well, I have my data on rotating disks. That makes sense to me. That's cost-effective place to park the data and to have it live and to protect it using RAID. Now, that's all good, but I need higher random IOPS. So I'm going to take and I'm going to put a third-party flash appliance between my servers and my legacy rotating media storage system. This I do not recommend. This is the worst of the 4 scenarios because you're going to get into some finger pointing where you have a really old storage system that can't take flash. You try to band-aid that with someone else's third-party caching appliance. The performance isn't there, or if anything happens, the finger pointing will begin. Whose problem was it? Blah, blah, blah. So that one I personally have that would be the lowest on the totem pole. One of the finest ways to use flash is to put it directly into the storage system so that all of the servers will have their random I/O numbers be very appetizing. And also it's managed as an integrated unit as part of the storage system under one management console. So this turns out to be a very, very cost-effective way to get high random I/O throughput, which is, of course, important in those virtualized computing environments. It's a single system to manage, and it can provide both performance and capacity. So we're talking about unified storage, and the NST5000 is a unified storage system. What do we mean by unified hybrid storage? By unified, we mean that it can not only do the NAS functions, CIFS and NFS functions, but it can also do the SAN functions with iSCSI. And by hybrid, we mean that it not only uses rotating media, like up to 5 petabytes of SATA drives and up to 130 terabytes of SAS drives, but it also uses solid state. And that's a broader term. I didn't say it uses flash. I said it uses solid state, because we do use flash for the read cache, and then for the write cache, we use DRAM and NVRAM, which is 20 times faster than flash for the write cache and never wears out. So I'll talk a little bit more details about how FastTier works further on. But that's what we're talking about, unified hybrid storage. And of course, it leverages the E-Series. So what you can see here is the picture of the device picture that you see here is the NST5000 head. It's a 3U head. It has 16 bays across the front. It has dual controllers. It's, everything's fully fault tolerant. And the 16 bays across the front, you typically do not put drives into those bays. Instead, you put just flash into there. So it's FastTier caching goes into there. The data lives on the underlying E-Series disk arrays. And so I've got a rack full of E60s here with an NST5000 head at the top. And what you end up with is a system with excellent reliability, density, and power management, because those are some of the key attributes that the E-Series brings to the party. And then in terms of the head itself, it's bringing you scalable performance. So you can go in and you can have anywhere from 8 to 24 Xeon cores. Memory can range from a very healthy 24 gigabytes to a very, very healthy 192 gigabytes. The FastTier caching can be, you don't need to have it in there at all. That's, flexibility. We definitely do sell NST5000s with no FastTier cache in them. Just for general bulk storage, it's an awesome system, very feature-rich, has all the enterprise-class features in it. Or you can introduce some FastTier cache, and I'm going to talk more about that in a minute. The other thing you have working for you with the NST5000 is that all of those E-Series have dedicated RAID engines down in them. There's 4 dedicated RAID engines per E-Series. And those are cranking out the RAID 5 and RAID 6 calculations, helping further to offload the Xeon core processors to do more valuable work. You really want to have dedicated hardware to knock out RAID 6 calculations. It's important. And you end up with a system that starts at 40 cents per gigabyte and $1.60 per op. The magic is the FastTier cache. And what we have is some of the best caching architecture and software in the industry. And now I'll tell you about it after I tell you on this slide. And if you don't agree that this is the best caching you've ever heard of, then I will stand corrected. Just send me a little chat message. But what we've got is the caching. So the data actually lives on the underlying rotating drives, and those are rated. So that data is protected. And now what we want to do is we just want to bring up the random I/O performance of the system, and so we implement the FastTier cache. And for read cache, we'll use these flash drives, and you can have up to 9 terabytes. That's a lot of cache. That's the size of a solid-state storage system, isn't it? Some of the smaller ones. I mean, they only go up to 20 terabytes typically, maybe 40 terabytes for a solid-state storage system. So, having 9 terabytes of cache, what will happen is working sets will migrate into the cache, and you will be operating at flash speeds. So there's no need to RAID our SSDs that we use in this read cache, because should a device go bad, we'll just reissue the write to the underlying rotating media. Why am I making a point that we don't RAID the SSDs? The thing about SSDs, they might be fast, but they wear out. And you want to limit the number of writes that you make to SSDs. Now, if you're going to take them and put them into a RAID set, every write becomes 2, right? Because you're going to have to write the data that's being changed, and then you're going to have to write the checksum. So that means you're going to drive your SSDs to their grave twice as fast. So what we do is we use the flash devices for a read cache, and since it's read-only, you don't need to RAID them. Now, this caching takes place on demand in real time, so you won't feel any impact in the system from the fact that this caching operation is taking place. And not only do we cache the information as it's being requested into the flash, but we also will anticipate. We'll do opportunistic read-aheads, for instance, to pull in data, especially if you're doing sequential accesses, to pull in data, so that it's there when it's already in the cache when it's asked for. The other thing is the write cache, and I'm seeing a question here, how does this compare to Nimble? So I'll kind of cover that as I cover the slide. Thank you, Wayne. So the write cache is something that Nimble doesn't have. The write cache is fully fault tolerant on the NST 5000, and it is a write back cache because it is fault tolerant. So here's how it works. When a write transaction comes into Controller 1, it gets put into the write journal of Controller 1. It is also put into non-volatile RAM. And the non-volatile RAM can be accessed by either controller on the system. So if Controller 1 dies an unexpected death, Controller 2 can pick up all of the pending write transactions and complete them. So you never lose a transaction. You never lose a write transaction. We're proud of the fact that we have a fault-tolerant write-back cache, and it really shows up in the benchmarks. I love demanding databases. It really shines here because as soon as the competition has to do a write, they freeze in their tracks because the write has to go all the way down to the rotating media. So it's nice to have a write-back cache. And also in virtualized environments, especially for, people talk about boot storms and so forth, but you can definitely slow things down as the writes begin to occur. The granularity of FAST here is awesome. You'll never hear anyone else in the industry. I've not read, and I do the competitive analysis here, I've not read anyone that is claiming better granularity for their caching. Here's how it works with FAST here, especially important for you guys, okay, in media, because what I can do is I can take a system, an NST 5000 system, and I can have, let's say, 320 drives in that system. Now I can put a ton of FAST here in front of 120 of those drives. I can put a medium amount of FAST here in front of 80 of those drives, and the rest of them get no FAST here. See, because FAST tiers per disk pool, so you can have as many FAST tiers in the system as you feel is appropriate. And if you don't need it, you don't have to get it. Now, when you compare this, Wayne, to like a Nimble system, they only have SATA drives. We have SATA and SAS. They have very, very limited configurations and scalability. We go up to 5 petabytes. They don't have a write cache. We do. They always give the same amount of flash cache to rotating media. It's always a 16-bay across the front system, and 12 drives will always be SATA, and 4 will always be flash. So it's not, that's it. That's what you get. So it's sort of a fixed brick. We have configurations of the NST 5000 that match each and every Nimble configuration, screw for screw, spindle for spindle, only we outpace them because we have all the enterprise class features in our system, and so that's definitely something that we'd encourage you to contact us and we can talk further about. There's no manual intervention required once you put your fast tier cache in place. This is important because, in contrast to like auto tiering systems like EMC's Fast VP or Dell Compellent Fluid Data Motion, those things come with 300-page manuals on how the automatic tiering is going to work, how data will land on 10K SAS drives, under what circumstances will it be migrated down to SATA drives, under what circumstances will it be migrated up into SSDs. The system's basically thrashing, trying to rectify all of these different storage policies. This is not how fast tier is working. Fast tier, it's a true caching tier. No data lives in the tier. The data always lives on underlying rotating media, which of course are rated for protection. And there's a white paper. You can come to our website. I wrote an entire white paper on fast tier caching. So where this leaves us, just sort of backing up to the business level, is we have this hybrid storage system. It's pretty good because it can do both the SAN and the NAS functions, and you really don't know what your mix is going to be looking out 5 years. Who needs SAN? Who needs NAS? At least with an NST 5000, you've got the flexibility. And you can tune performance and capacity separately. It's not just a scale-out architecture like EqualLogic bricks, where if you need more performance, that comes with drives, and if you need more capacity, that comes with controllers you might not need. With the NST 5000, you have flexible scalability, and we're able to take you anywhere from, I can put no fast tier into the system, and it will be operating, at the, down here at the cost and performance of rotating media storage system, a really good one because our controllers are monster controllers in this thing. Or I can put more fast tier cache in it, and then your working set will migrate into the cache, and you'll be operating at all flash speeds. And these prices, starting at 40 cents per gigabyte, I actually put 1.2 terabytes of fast tier cache on that system. And for the $1.60 per op per second, I actually had 1.6 terabytes of fast tier cache on that. So these are starting at prices, but they give you the ballpark, and they should make you sit forward in your seat because these are some awesome values. And with fast tier, with the solid state being done so well, you guys might want to change the way you think about how you configure a storage system. And we're not the only ones saying this. EMC has the same message with their VNX product line, that the solid state can make a big difference, right? Because they have fast cache, which would be somewhat, it can't hold a candle to fast tier, but it is caching. So let's take a look at it. Before there was solid state, the way I would give you 100,000 ops per second of performance is I'd use 300 SAS drives, and I'd probably short stroke them. There would be no fast tier because this is before fast tier exists, and you'd be looking at about 27 U of rack space. It would be expensive, but hey, it's Nexan, so it's an excellent value. If you bought a competitor, you'd be paying 2-3 times as much for your 300 SAS drives. Right? And this is with the same rock-solid reliability that we're known for. Now, another way to go, if you enter fast tier into the picture, I can use maybe 100 SAS drives. And you know what? They can be 10K. They don't have to be 15K. And fast tier is going to make that system perform at 100,000 ops per second. You'll be in 11 U of rack space, and you will have saved a lot of money. Another way you can go, though, and this is what I was saying, we're not the only ones that are advocating this fast tier plus SATA. EMC also is beating this drum. I can give you really good performance. I can give you 54,000 ops per second of random I/O performance using just 10 SATA drives, because fast tier is what is providing the random I/O. And now you'd be in 5 U of rack space, and you've saved yourself a boatload of money. So here's the question you need to ask yourself. A lot of the operations that you're doing do not need random I/O performance. They need sequential performance. But for those operations that do need random I/O performance, do you need more than 54,000 ops per second? Probably not. And so you see how you can save rack space, save power, save a lot of money. So definitely something to consider. Now, when it comes to the fast tier cache itself, and with this product, the NST 5000, we've had out in the market for 2 years, and we've been using SSDs that were more expensive. And last month we introduced the eMLC SSDs into the product. They have 5-year lifetime, which is what we were looking for, and the price of the fast tier cache got cut in half. So enough on the cache. How about just the storage that's in your NST 5000? Now, if you don't need a lot of features, you can just use the E-Series straight up. But in this talk, because I've assumed that you have VMware in the picture, you need an NST 5000 head if you've got VMware in the picture, and it's a demanding environment. If it's not demanding, hey, E-Series will be just fine. But the NST 5000 lets me bring in fast tier, so I know you're going to be happy, and I know it's really granular, so you only need to buy just the right amount, so it has an excellent value to it. But here's the different ways you can store your rotating media. You can put them into an E18, and that would give you, 18 drives. You can see here I can use 18 4-terabyte drives, and that'll get me up to 72 terabytes. And then I can put an expansion shelf underneath the E18, which will give me another, brings me up to 144, and then I can put another expansion chassis under that. Or, if I really feel I need the performance, I could buy 3 E18s and just put them all under the NST5000 head. The advantage there is that I'm going to have 3 times 4, 12 RAID engines working for me. But it'll be more expensive. We also have, the E-Series comes in small, medium, and large. So we have the one that has 48 drives in 4U, and then we can do 60 drives in 4U. And then we have a couple of JBODs also that you can put under the NST5000 head. And some different I/O is listed here. I won't go into the details of this talk, but it's just it's on the slide for completeness. So about these E-Series, these are truly awesome disk arrays. They stand out from the crowd in the industry, and that's not easy to do. A disk array, how do you stand out when you're a disk array, right? Do you do fiber channel, and do you have disks in you? Okay. Well, there's lots of things to look at. The first is the reliability. Reliability is the most important thing in this industry, and we happen to be the leaders in reliability. How could that possibly be true? Well, here's what we do. We take all of the drives that come into manufacturing and we hammer on them with a proprietary patented stress test. So they might all look like they're good drives coming out of the drive manufacturer, and for other storage vendors they are. They're all fine, but not to us. We will find that 5% of drives that are the weak ones, and we kick them back to the manufacturer. That means you're not going to be looking at RAID rebuilds, which I'm sure you don't want to have to face. And your total cost of ownership is going to go way down because we have knocked out the weak drives. Not only that, we test them in the system. There are competitors that all of the testing takes place when you put it together in your shop. That's where the system integration test takes place. We don't do that at Nexan. We test all the drives in the system for 2 days of burn-in to make sure everything's happy, and then we unpackage everything, package it all up the way it needs to be and ship it off to you. So we did the integration test. And then the chassis itself is unsurpassed. We have an anti-vibration design where we mount the drives counter-rotating so they cancel out each other's vibrations. You have to manage vibration in a dense storage environment. And the other thing you need to manage is cooling. So we have fans in the front and the back. We call this Cool Drive technology, and it's fantastic. You get a message that says, oh, fan out. Isn't that like a panic message where you need to rush into the office because your hard drives are frying? Well, not with an E-Series, because there's a push. We pull the air in the front and we push it out the back. So even with an entire fan assembly out, there's air moving over your drives, which is good. And then there is, you can see the densities here on the slide, the 60, the 48, and the 18 drive. And then we have this active drawer technology. If you have a storage system, with 60 drives in it or 50 drives in it, and you need to service those drives, that entails moving a 200 to 300 pound storage system forward in the rack. And if you read your manual, it says on many pages of the manual of our competitors' equipment that you could really hurt yourself if you pull that forward in the rack. That's why we have Active Drawer, because if you need to service the drives or the fans, you just pull that drawer forward, and you can do so while those drives are being used. So you can service the system without it coming down on you, without the rack tipping forward, and with no downtime to end users. And most importantly, no cables get pulled out of the back. Right? The power cables, the fiber channel cables, the iSCSI cables, the Ethernet cables, those things can get pulled and twisted if you're pulling the entire storage system out. On our system, that back panel doesn't move. The drawer has like a little window shade ribbon cable going that brings all of the services out to the drives. It's truly revolutionary, and people really love it. And again, it adds to the reliability of the system. That's the main thing. Our controllers are active-active, which is surely what you're looking for. And if you have a project, video project that you've got parked, just some B footage, just sitting, just storing it away, then Automate is your friend. Because if there's a disk pool that hasn't been hit for the last certain amount of time, those drives can be put into a lower power state. The first thing we'll do, you create policies for Automate, and then they just kick in. So the first thing we'll do is maybe you say, hey, if no one hits any drives in this pool for 30 minutes, go ahead and put it into, go ahead and unload the heads. Well, that'll save 25%. We just move the head to, out so it's not exhibiting the wind resistance, and you save 25% on power right there. We can also slow the platter, we can stop it from rotating, we can turn off the drive electronics, and you go into lower and lower energy states. Now, as soon as one person touches one drive in that pool, because they needed some information from it, either a read or a write, the entire pool will spin up and they'll get their information. If you're in your deepest level of sleep, it'll take a minute to spin up. So it's not something you want to set your policies wisely. It works out really well for video folks because you're parking information for long periods of time. And the other place that Automate really comes in handy is for backup to disk. Because if you're in the backup window, all the drives are spun up, it's full performance. But when you're not backing up, which is the other 16 hours of the day, then the drives can go into a lower power state. So bringing it all together then, you've got the NST 5000 comes in 3 sizes, small, medium, and large, 5100, 5300, 5500. You can see here the different numbers of Xeon cores that are in each of the different models, and then your choice for SATA drives or NL-SAS drives, which exhibit the same performance. It's just a little different architecture. Our controllers are so smart that there's no difference between a SATA drive and an NL-SAS drive. But that's not true at some of our competitors. Their controllers are too dumb, so they need that dual-ported NL-SAS drive. We can go either way. We're good either way. So we can go up to 5 petabytes on the NST 5000 with the SATA drives, and then you can also introduce some SAS drives. You can have multiple disk pools, and we can mix and match drives in these systems. So then you can choose your fast tier cache. There's the write cache, the 8 gigabyte NVRAM, and then for the read cache, you can choose MLC or eMLC or SLC devices. They have different costs and lifetimes. So just pick what's right for you there. And then I/O. So the I/O on the front end, you can come in using GigE. You can go up to 12 GigE going into the system, or you can have 4 10 gigabit E. And that's where all of your CIFS, NFS, and iSCSI traffic is going to come into the head. And then the way the head talks to the underlying E series is either using fiber channel or a bunch of SAS by 4 connections. And if your switch permits it, we can trunk. So you might have 12 gig E's, and we can trunk those together into one big fat 12 gigabit pipe, which is nice. And this is how you get up to 5 petabytes. This is new. We used to have a maximum of a petabyte on the 5500, but now recently, last month, we announced that you can buy a pair of SAS switches and put them into place and have a completely fault-tolerant configuration that can go all the way up to 5 petabytes. That would include 1,260 drives. You'd have 14 E-series controllers in the picture, which means 56 dedicated RAID 6 engines. So it's a really big configuration. But regardless, whether you need 9 terabytes of storage, which is what the NST 5000 starts at, 9 terabytes, give you like a half-populated 5100, it's 9 terabytes, or all the way up to 5 petabytes, the fact is you want enterprise-class software that's easy to use. And so the feature set is definitely here. It's unified. It has thin provisioning. It has, when we're under VMware, we do the dead space reclamation. So if VMware is doing the thin provisioning, they call us, we'll thin provision and dead space reclamation underneath VMware. You always want to ask about dead space reclamation. A lot of vendors forget that. We have quotas with oversubscription, which is sort of the same thing as thin provisioning, only it's for shares, for CIFS and NFS shares. We have online capacity expansion, which means you can add more physical drives into the system on the fly while it's being used. And our snapshots are the best in the industry. It's redirect on write snapshots. So there's no performance penalty. You can snap all day, all week. You know, there's 2,048 snaps per share or per LUN. And you do not need to pre-reserve storage to hold the snapshots, right? Like on a VNX, that's a copy on write. So every time you do a write, it turns into a read and 2 writes. And also with a VNX, you need to pre-allocate like 25% of your disk storage to be, quote, data protection storage. So it gets to be very costly. Here with the NST5000, you do not need to pre-allocate data protection storage, and the snapshots are just pointers. It's just like it's redirect on write. There's no copying that needs to take place. We do have a Microsoft VSS hardware provider to give you the best possible backups of Exchange and SQL Server, SharePoint, Oracle, really any mission-critical application that runs on Windows adheres to the VSS infrastructure. And we've implemented all of the VAAI extensions, which I have a slide coming up on, to offload those key operations, because those can definitely bottleneck your vSphere server. So I have a slide just on that. Asynchronous replication, of course, will be important. So you just buy 2 of these 5000s, you put them any distance apart, and all of the snapshots that are taken on the source side will be transmitted to the destination side. And that way you can fail over, fail back between the 2 systems. Or a lot of times what people do in video is that for distribution, they'll distribute off of the replica. Why not? That makes sense. Or they'll distribute off the primary NST5000. Should a problem happen there, they immediately start distributing off of the replica. So we also have synchronous replication for high transaction environments. We do data scrubbing periodically. We have all of the security built in for SANS and also for NAS. And for backup, there's NDMP. So whatever your favorite backup and restore application is, you'll be able to use it with the NST5000. And the management of the system is really a dream. It's so sweet to use this. And I was having some trouble describing this user interface, but it's gotten a lot easier because the world has caught up with Nexan. So these wheels that you're looking at, when you go to manage the NST5000, you use the eCenter Manager, and it will manage all of your NST5000s across all of your worldwide sites and all of the underlying JBODs or E-Series that would be under those heads. So it's all from a single pane of glass, which people like. And the GUI is gesture-based. So we've got a series of rings that can bring you to the object that you want to manage very quickly. You know, gestures are a great way to just flip through large collections of things, way better than a tree control. And if you're using an iPhone or an iPad or even now Windows 8, it's all gestures. There's a reason for that. It's extremely efficient and natural. And when you're not going in and, if you're a power user, you're like, hey, take all your GUI and get it out of my way. I have scripts. I have Unix scripts that I'm using to manage my data center here, and that's fine too. We have a full and robust CLI for managing the system, and you know what? You can switch between the two, CLI and GUI-based management. I might be a CLI fan because I like my scripts, but you know what? I love my wizards. I love this list of wizards that's here. They really pull me through the operations. And you know, I need that. I'm in marketing. You know, I need the wizards. So they really help me to get the system set up, establish storage pools, establish shares, what my snapshot policies are, get asynchronous replication to a remote site. You know, you can get 2 NST5000s set up with shares and snapshots and asynchronous replication in 5 minutes. You may have heard marketing people throw out small numbers before, but we tested this with end users. Actually, everyone finished in under 4. So it's really very, very productive for the IT generalist, and I know you want to focus on your video, not on managing your storage system. The thing about vSphere is that, you know, your vSphere server is critical. So you're going to have 2 because, you know, if one goes bad, you got to switch over to the other one. And the other thing about the vSphere servers is that they tend to become overwhelmed. They're typically running 14 virtual machines each, and so VMware is going to want to do some stuff like load balance and move a virtual machine from one vSphere server to another. Or they will want to do a storage vMotion where they move a LUN from one storage system to another, things like that. And so what they can do is they can use the full copy operation. They call down to us, and we do that movement. We do that bulk data movement. So it really helps to offload the vSphere server tremendously. Also, for hardware-assisted locking, what happens here is you've got the VMFS file system, right? And you've got, and we've served LUNs up to vSphere, and who's using that LUN? If we give a LUN to vSphere, which virtual machines are using that LUN? Well, a lot of virtual machines, and maybe too many. So what you used to have to do, we have a standard rule in computers, right, which is many readers, no issue, but one writer. So someone has to have the key to the LUN if they're going to write. So rather than having to lock the whole LUN, which can lock out some of the other virtual machines, now VMware can lock parts of a LUN. They have what's called hardware-assisted locking. It's a test and set operation. It's very, very quick. So we've implemented that. Also for zero blocking, let's say I have some storage that I provided up to virtual machine 1, and now it wants to give it back to me. Great, I'll put it in the pool and give it out to virtual machine 3 because he needs some more over there. But you know, you can't just be handing dirty storage to virtual machine 3. That would be a complete security breach. So you got to zero it out. So what? VMware used to say, zero this block, and then you come back and go, done. And it goes, now zero that block, and you come back and go, done. And it goes, now zero this block, and you come back and go, done. That's kind of inefficient. Now they say zero from here to here, and we say done. So that's zero blocking. And then the thin provisioning reclamation is, again, vSphere has provided out some storage to a virtual machine, and it was actually thin provisioned, and now it's coming back, so you need to do cleanup and consolidation of the underlying storage. So we've implemented that. This is how you overcome your virtual machine bottlenecks with things like fast tier cache, putting the right amount of I/O into the system, being able to mix and match SAS and SATA drives so that you can get different performance profiles, and these VAAI operations that help to offload the LUN, the LUN activity. And we'll be implementing for about 3/4 of the people store their virtual machines on LUNs, and about 1/4 store their virtual machines on NFS. We don't have a religious one way or another on that, and so we'll be implementing these VAAI calls on NFS next. So that's something to look forward to in the future, the not too distant future. And so let's just take a look then at where we're at with the NST 5000. We've got the fast tier cache working for us that reduces the number of spinning disks that we need to purchase, and at the same time is boosting up the random I/O performance, which is very, very commonly a bottleneck in the system. We've got the AutoMade technology that's going to bring down the power and cooling bill for sets of data when you're not hitting on them. We've got the drive stress testing and the best chassis in the industry, bar none, which really increases reliability and brings down total cost of ownership, and the whole thing's easy to manage. CLI, GUI, local, remote, all the systems, we've got it worked out and it's smooth. So the types of applications then that you can put the NST 5000 to certainly are virtualized environments, which is the main focus of this webinar, but also it's just a darn good NAS box. Buy it, put a ton of SATA drives in it, and don't put any fast tier in it. And later, if some people need some certain, higher levels of random I/O performance for some reason, you can put some SAS drives in. You're good. And if you need to go further, start applying fast tier to those pools of drives where it makes sense. It's just awesome. The configurability and how it can satisfy what you need today and be morphed and changed to give you business agility going into the future. Great for databases, obviously. So Tenacia came out and said, hey, with the advances in solid-state drives, you can get much higher performance and lower latency. Customers don't have to sacrifice simplicity or budgets to get their performance improvements. And this is after they had reviewed the Nexan system, so we're very happy that they were able to provide that quote for us. So that, in a nutshell, is the, oh, got a question here. I'll take that in a second, I guess. So if you want to learn more, you can come to our websites. Right? Come on over to Chesapeake Systems, who's hosting this webinar today. You can come to Nexan, find some white papers and deeper thinking, see some of my chalk talks on some of these things, and so forth, and get all the details on the 5000, the data sheets there, and so forth. But in terms of the personal touch and interaction, obviously that's with Chesapeake Systems. And so with that, I'm just going to take a look at some of these questions here, Dave, and see what I've got. There's one here from Nagesh, and he says, do you have support for VMware VASA? Nobody does, because VASA is vSphere 6, and we're at vSphere 5 right now. But when vSphere 6 comes out and hits the market, we're going to be there with support for that as fast as possible. So we got some boys working on that, but it's not, you can't deliver the product because there's no vSphere 6 yet. I have another question here. Do we have deduplication? Well, you know, our system is based on ZFS, a proven enterprise class file system, but we removed modules, we rewrote some modules, and we turned some functionality off. And one of the things we turned off was deduplication, but we're going to be turning it on before too long. And the way we'll allow you to do this is we will allow you to do it on a per disk pool basis, which will be cool. What else do we have here? How would Asurion fit into these setups you describe? Okay. The main thing about an Asurion is it's a great offloader. There's a little client you can put onto your Windows server, and it will offload information from your primary storage and squirt it onto the Asurion, which is a worm archive appliance. The thing is, once you, and it leaves a shortcut in its, you take a file off of a Windows server, you put it onto the Asurion, leave a shortcut in its place. That's typically what people do. And while the Asurion is super secure and super reliable, that may be of interest to you. But one of the big features is the fact that it can do automatic offloading. So, you know, if your primary storage is filling up, you have a choice. You can buy more primary storage, or you can offload it. Turns out 50% of that information can be moved onto an archive device, and you'll be better off, because not only have you freed up primary storage, but now when you do your backups, you don't have to lug that stuff around, because once the data is put into Asurion, Asurions work in pairs to protect your data, geographically separated pairs if you can do it, to protect your data. So it streamlines backups. Can you support remote deduplication to another Nexan in another location? Yes. Before the, okay, so you got your primary, and then you got your remote, NST 5000s. And on the primary, you're taking your snapshots, and all the deltas since the last snapshot are transmitted to the target side. But the thing is, we look really close and do a deduplication. So if there's information that's already on the target side, we won't send it over. So yes, we have great dedupe tied to our asynchronous replication, but we do not today make dedupe generally available on the NAS box, but you can look forward to that in the future because it's built into ZFS. We just need to turn it on. Where's the white paper? The white paper. Well, I don't have a white paper on us versus EqualLogic, but I do have papers on it. I've done competitive analyses. EqualLogic is the scale-out company. So you buy bricks, right? You buy 2 controllers and a set of drives, and then you buy another brick and another brick and another brick. And they always have 2 controllers and a bunch of drives in them. They do not have anything like fast tier caching. I know they have the hybrid brick that comes half with SSDs and half with SAS drives in it, but you know what? You need to know which, when you expose those SSDs out to the servers, you have to expose those ones and know which servers and which applications are using them. So it's really nowhere near. It's not automatic tiering. and it's not, which you can get with your Dell Compellent, and it's certainly not SSD caching. It's no fast here. So that's the biggest thing about EqualLogic is they're like late to the SSD show. And the other thing is, just like I was saying, capacity and performance always move together with the EqualLogic. With us, you can tune those independently to your needs. Okay, it's not half and half. There's one. Okay, all right. There's a brick that has full SSDs. Everything else I said, remains the same. Sorry, I didn't realize they had a full SSD brick that you could put in. But it's not caching and it's not automatic tiering. So. Does automatically, yeah. All right. So we can go in further, deeper on that later. Someone wants to have a longer conversation. Let's see what else is in here. Can you scrolling through? I think we're in pretty good shape. Okay, great. So I think that does it. Hang on. What do you use for NVRAM? What type of technology is used? Okay. What we use today can change in the future. The important thing at a high level is that we do have NVRAM so that the writes will be protected in an abrupt power down situation, right? Even if the customer doesn't have a UPS. So today, the NVRAM in the NST5000, it's like a drive that plugs right into one of the 16 bays across the front of the NST5000. So it appears like DRAM, and it has all of the speed of DRAM, and it has a super cap in it, and then it has flash. But the only time you use the flash is on abrupt power down. Upon abrupt power down, the super cap moves the information from the DRAM and pushes it into flash to protect it for indefinite amounts of time. Okay. And I don't understand that question. Sorry. Are hardware and software upgrades non-disruptive? Yes. What you can do with our E-Series and also our NST is you would typically, let's say you're going to do a firmware upgrade to the controller. That's the nastiest thing to do, right? You just do a rolling upgrade. So you manually fail over to one of the controllers, and then you upgrade the firmware on the one, and then you get that thing up. Then you manually fail over to the one that has the new firmware, and then you upgrade the firmware on the second one, and then you bring them both online. So yeah, you can do rolling firmware upgrades. And okay, so that's the bulk of the questions. There's a very long list here, so if I've missed your question, get in touch with someone at Chesapeake. We'd be happy to get a storage specialist to get that answered for you. And with that, I would like to bring David back. David?
Hey, Don.
Hey. So we're just in a sign-off mode at this point.
Absolutely. Very informative. Thank you very much. And we look forward, again, folks know how to reach us. You have it right there on your screen, chesa.com. Talk with Nick, Merrill. We'll be glad to work out solutions with you.
Great. Thanks so much. And again, I apologize if they're a little, we've delivered over 200 pizzas all at the exact same time, which I thought was impossible, but there were a few gotchas, and we apologize. We really feel bad about that, and we'll make it right for you. We've got all this chat I've got a record of, and we'll follow up with anyone that we need to follow up, okay? So thank you very much for attending today, and have a great day. With that, this meeting is adjourned.